Hello, this is Karston Evans, and this is my lane detection homework for ENME489Y. Run this code, and here is my lane detection at work. Blue for the left lane, green indicates the right lane, and it will try to follow the lines as best as it can. I kept most of the detection pipelines we made in class. I had to change some to account for the second video, which has different lighting, and then I also had to change it up a little bit for doing a video rather than just a singular image. My first step to doing that was I had to capture the video, which is done here. I had to get the FPS of the video, which vid.get with this call. I need the FPS to later make sure this video is at the correct frame rate. And then I had to read the video to get each individual frame, and then it pretty much treats those frames as same as the image we did in class. But I resized the image to the same size as the image we did in class, just so it would better work with the polygonal mask that we had. Let me run the second video. So this one works as well. There is some distractions or some noise that will swing some of the lines to the away from being completely accurate. But I had to change the threshold image function a little bit to better incorporate the lighting in this video. So I played with the lower and upper bounds of the HSV colors, and as well as change the threshold for the black and white, and then I combine those with the bitwise OR to return a mask that uses both thresholds of a grayscale video and the HSV video to find the lines in more lighting, more dynamic lighting. I also adjusted the blur a little bit to better account for the noise. I kept the same function to determine the edges, and huff lines is the same function, and then the rest I had to make on my own on determining left and right lane lines. So I had to make a bunch of variables up here for the different points. I set them to 0 to start, and also the theta, the lines, which is the slope, and then the rho, which I believe is the y-intercept of the lines. So most of this is similar to what we made in class. And then I also declared lists. So these lists, left theta will include all the thetas determined by huff lines that are on the left side, so for the left lane line, and then right would determine all the right ones, and same with rows. I do that with determining whether the theta is greater than 0 and less than half of pi, and then that would be for the left lane lines because it's a positive slope, and then theta greater than pi or less than pi and greater than half of pi. That would be determine the right lane lines because it's a negative slope. And then I called my own function right define lanes. In that function, you take the median huff line of the huff lines that they provide. I do that by calling that list I had of thetas on the left side. Yeah, here's the left side one. So I if there's, oh, first I declared a shift, which was to shift it for the main video, since the huff lines on the snip will be placed in a different location than on the actual video. But so as long as the theta value, as long as there is a theta value, so as long as a huff line exists, pretty much this will run, and it will take the median. But the only issue, the way I have it is, the issue is that if median will, calling the median of the list, if it's an even number, it will take the average of the middle two numbers, and that ruins my indexing code. So if it's an even number and it's greater than 1, if there's even number of huff lines and there's more than one huff line, I just pretty much pretend there's one additional huff line at the bottom of, or I pretty much pretend there's one additional huff line by doing this append. And then I find the median with this, and then I find the index of that, like, so where it's located in the list with this function, and then with using that, I average the previous theta I had with the new theta I have, just so it's the noise doesn't affect the lines quite as much. And then I do that same with the row, and then I take the row index, so that would be the row corresponding to the median theta, and I do the same functions that we did in class to place it onto the snip, and then a similar thing for the video. I just had to shift it down a little bit, so the Y, I had to add this shift. And then I also played around and changed these values, so right in -1000 and -200, -200, just so the lines wouldn't go off the page entirely, off the video entirely, so that it just had a better look to it. So I make this one blue, and then here I have an else if statement. So if there is no huff lines, but there is a previous point, or points, it would always be, from earlier, then it will use those previous points, so that the lines don't just disappear. So I do the same exact thing that I just explained for the right lanes. So then I use these functions to show the snip and then the lanes detected. And then here I set with this wait key, I set the frame rate of the video. So I took the frame rate that I found earlier, took the inverse of that to get the seconds per frame, but I need that in milliseconds, so multiply it by 1000. So that's what I have there, and then this function right here, if I hit Q, it'll cancel out the video, so it's easier to exit. And then that is all for my code. Some improvements I could definitely make would be to play around more with these thresholds for the image, and that is because as you can see, it detects kind of some of the hues and stuff kind of pop in, which skews these lines. Also, another thing would be when this video just starts, the camera warms up, I believe, and that's why it's like really bright at first, and it kind of is detected in this threshold, so it makes lines that are, bogus. And initially I have actually the lines at 0, and then since it's an average they have to slowly move up, which takes about like a second, as you see when I just start the video. So those, yeah, so those could be improved by just maybe having like a delay before the lines even show up, or have the camera already running before starting the code. And that is all for my lane detection algorithm. Here is my final Python code.